Hey guys, I'm Yari Dareglia of Jump Zero. In today's lesson we'll have a gentle introduction to pointers, a topic that you have to master if you want to fully understand how Objective-C works. To better introduce the topic, we'll start with an overview of how memory works, and then, at the end, we'll move to some code examples. During the execution, a program needs memory to allocate its data. There are two types of memory, the stack memory and the heap memory. The stack is a static memory, where data grows depending on the current scope. For example, when you enter a function, the variables created in this function are allocated in the stack. When the function ends, this memory is released. The heap memory has a different behavior. The objects stored in this memory have no dependencies with the current scope and can be accessed randomly at any time. The tedious part is that you are responsible for releasing the memory when those objects are no longer needed. Don't worry though, because in Objective-C we have a cool feature called ARC that takes care of that for us. I showed that to you in a couple of lessons. Every object created in Objective-C is created in the heap memory, and only a reference to the object is stored in the stack. So you can access objects using a reference, also known as pointer. Let's introduce references and pointers by describing a simple situation. We create an integer value called I. This value is stored in the memory at a specific address that is described by an hexadecimal value like 0x1000. So, in the I variable, we have an integer value equal to 4, and the address of this value is 0x1000. When we need to get the address of a variable, we use a special operator called reference and describe it by the ampersand. So we can print the address of the variable I through nslog using the right wildcard, the %p. A pointer is a data type like an integer, but rather than a generic number, it stores a memory address. We define a pointer like any other data type, but using the star character and the type of the pointer. So for example, we can define a pointer to an integer with this code. Now we can set the value of IPTR with the address of I, simply by accessing it with the ampersand, as I've shown you in the previous example. And obviously IPTR2 has its own memory address, for example 0x100f. Now let me introduce a new operation called dereference. The star PTR assumes two different meanings, depending on its position. We can use a star PTR to the right of the equal. In this case, we use the R value of the variable. Passing through the address stored in the pointer, we obtain the stored value, that from the previous example is 4, and we assign it to B, at a new memory address. So, using the star to the right of the equal means give me the value stored at the address stored by the pointer. Similarly, if we use star to the left of the equal outside a declaration context, we get what is called the L value of the variable. In the same way shown in the previous slide, we can access the value of I through the memory address stored by the pointer and change it, for example to 25. So using the star to the left of the equal is like to say, put the value to the right of the equal into the address memory stored by the pointer. This practice is called dereference. Okay guys, this example has nothing to do with the heap memory and objects allocation, but this is an overview of what a pointer is. There are many other things to say about pointers, but for this course is enough to understand the simple rules I've shown you today. I merely want to be sure that when in the next lessons you find a star in a declaration, you say, okay, it's a pointer, and you are comfortable about what a pointer is. So guys, that's all for this lesson. Next time we speak about classes and objects. So thank you again for watching.